This video is on acid and base homeostasis. As you know, your kidneys are very important for keeping acid-base homeostasis. Kidneys. They do that by controlling high H plus and bicarb levels. And any changes it does, we call metabolic changes. But you should also know that your lungs are very important. Your respiratory system is very important for acid-base homeostasis. Yeah? You have CO2. It's all right, respiratory CO2, which is an acid. And if you want to get rid of that acid, you breathe faster, breathe it out. If you want to retain some acid, then you slow down your breathing. You kind of retain that acid. And any changes that your respiratory system does to maintain your acid-base homeostasis is called respiratory changes. So these are the two main players when it comes to acid-base homeostasis, and that's what we're going to talk about today. So just a few rules that you should know. Any changes in your body's not going to like that, right? It likes to maintain homeostasis. So if suddenly you have a retention of hydrogen and you get metabolic acidosis, your body's not going to like that. And it'll try to compensate for that. So rule number one, your body will try and compensate. By using the other player. So if you're getting metabolic acidosis, then to compensate, you'll get respiratory alkalosis. Respiratory alkalosis. So try and compensate. But you should know, rule number two, compensation techniques are never ever complete, right? They're never as good as the original. So I'll say never fully compensate. Never fully compensate. And last but not least, metabolic changes take longer. Because I mean, your lungs, if you want to retain more CO2, you can immediately stop breathing. If you want to breathe out more CO2, you can immediately breathe faster. Your kidneys have to take some time, right? Your kidneys' nephrons have to work. You have to pee. You have to do all this stuff. So it takes some time. So metabolic changes take longer. So those are just some rules that you should keep in mind. Now let's talk about acid-base changes. Your body keeps a very tight regulation of your acid-base levels. Your pH is usually around 7.35 to 7.45. And if you dip below that, we call that acidosis, don't we? So below 7.35, we call that acidosis. And above 7.45, we call that alkalosis. And so let's just talk about respiratory changes first. Let's talk about respiratory acidosis. Let's talk about respiratory alkalosis. What causes respiratory alkalosis? We said CO2 is acidic, right? So if you get rid of that acid, then you get alkalotic. How do we get rid of that acid? We breathe really fast. CO2 levels will be low. If you check the CO2 levels will be low. So low CO2. And I mean, the lab values are going to be on the step one. You can just pull it up. But if you're curious, it'll be under 35. Right? Because you're breathing out all that acid. You're becoming alkalotic. So causes will be hyperventilation. That's kind of the name of the game. Any type of hypoxemia, when your body's low on oxygen, it freaks out and tries to get more oxygen. So you breathe more. So any type of hypoxemia, so pulmonary embolus, you know that you cause tachycardia, you're breathing harder. And salicylate toxicity early on, because this stimulates your rest center, stimulates your respiratory center. Done. Not too bad. Let's jump on over to acidosis. Let's see what causes respiratory acidosis. Respiratory acidosis. We said that CO2 is a acid. So if you get acidosis, then that means you're retaining that acid. You're keeping that in. That means you're not breathing it out. That means you're holding your breath, keeping all that acid in, you're getting acidotic. So if you check your CO2 levels, it's going to be sky high. And again, lab values are on step 1, but if you're curious, it'll be over 45. Yeah, sky high levels. That's not right, it should be this way. What causes that retention? What causes you to stop breathing? Well, obstruction, self-explanatory. Drugs like opiates or sedatives, you depress your respiratory center. You're breathing like 2 times a minute. You're just very, very common cause. You can have weak muscles if you have muscular or neuropathic neuropathies. Then, especially if it affects your diaphragm, affects your phrenic nerve, you don't breathe as much. So I'll just write neuromuscular. And of course, things like lung disease. Okay? Hopefully that's not too bad. Let's jump on to metabolic causes. We said that metabolic causes are kidney changes. So either dealing with hydrogen or dealing with bicarb. So we'll talk about metabolic alkalosis first. Metabolic alkalosis. All right, metabolic. What happens in metabolic alkalosis? Can you figure it out? That means you're either retaining a lot of bicarb, getting alkalotic, or you're losing hydrogen. Either you're peeing out or you're losing it some other way. Some other way? What other ways? How about vomiting? Vomiting is a very, very common cause of metabolic alkalosis. I always ask, anytime we talk about vomiting, you basically throw up all that acid. Yes, stomach acid. You throw up all that stomach acid, you become alkalotic. You can take antacids. Antacids are alkalotic by nature. They're trying to neutralize that stomach acid, trying to neutralize that GERD. You could have diuretics, especially loop diuretics. You can also have increased aldosterone. You know what I'm going to ask you. What does aldosterone do? How does it cause metabolic alkalosis? Can you think of that? Here's your ENaC channel, takes in sodium, pumps out hydrogen, pumps out potassium. Hopefully you can like draw this in your sleep. Aldosterone works on this, right? And by working on this, it sucks in more sodium, pumps out more hydrogen, pumps out more potassium. You pump out that hydrogen, you pee out that hydrogen, you get alkalotic. Simple as that. Easy peasy. That's metabolic alkalosis. Now let's jump on to metabolic acidosis. You probably know why I'm saving this for last. It's the most confusing. Metabolic acidosis can be broken into 2 categories. Anion gap and non-anion. What the heck is an anion gap? Well, in your body you have cations and you have anions. You have positively charged things like sodium and potassium. And then you have negatively charged things like chloride, like bicarb. Yeah? And if you take the positively charged things and you subtract the negatively charged things, you should have 0. Your serum is neutral. Yeah, you should have 0. But when you do the math and you take the positive charge, subtract the negative charge, you actually end up with more positive cations. More positive cations. Usually the number is less than 12. This is normal. And you're thinking, wait, you just said it's neutral. Why is there more cations than anions? Why is there a gap? We call that the anion gap. Because unbeknownst to us, what's not in our formula is we secretly have some other anions. That includes things like acids, things like phosphoric acids, and sulfuric acids. All right. So if for whatever reason you're taking in some exogenous acids, if you're taking in some exogenous acids, if you're taking in some phosphoric acids, some sulfuric acids, then this mystery anions will increase. And when you do your equation, you're going to find out that your anion gap will increase. We call that anion gap acidosis. And it's due to increased exogenous acids. These kind of mystery acids that are floating around. Okay? What are some causes of these increased acids? Well, you can drink it, like in methanol. That creates formic acid. Formic acid. You can have diabetic ketoacidosis, ketones, acidosis, you get increased acid. You can have propylene glycol, or ethylene glycol. I think that's antifreeze, so that turns into oxalic acid. So ethylene glycol. You can have salicylate toxicity. Then we say salicylate toxicity causes respiratory alkalosis. Well, that's early on. Later on, it disrupts your cell metabolism and causes increased acid. So you can have that. Lactic acidosis. Again, we're increasing that acid. Anything that causes lactic acidosis. Iron. If you overdose on iron tablets, iron is a free radical. Damages your cell, causes your cell to release acid. INH, which is an anti-TB drug. It interferes with your Krebs cycle. That's some biochem stuff you don't have to worry about. But it interferes with your Krebs cycle, increases acid. Let's see if I'm missing anything. And then if you look in first aid, they list down uremia. Uremia isn't a cause of metabolic acidosis. It's a result. Kidneys are shot and you can't filter stuff, and so you get uremia. Okay? That is anion gap acidosis, and if the takeaway message here is that anion gap acidosis is due to an increase in these not accounted for acids. Okay? Now, non-anion gap is not going to be due to that. You just draw back out our stuff. We said that we had sodium, we had potassium, we had chloride, we have bicarb. And if you take the positive minus the negative, then it should be 0, but the reason it's not 0 is because we didn't account for our little mystery acids, right? Well, in non-anion gap, we're not messing with these mystery acids. Yeah. What causes acidosis in the first place? Well, it would be due to a loss in bicarb. And when you lose bicarb, then chloride will take its place, get reabsorbed, and increase. And that way you keep your anion gap balanced. And so your anion gap is the same. Anion is the same. Anion gap is the same. Sometimes they call it non-anion gap acidosis. Sometimes they call it hyperchloremic acidosis. It's the same thing. All right. So what can cause that decrease in bicarb? Well, how about acetazolamide? What does acetazolamide do? Blocks carbonic anhydrase. Great. You can have diarrhea, where you just lose bicarb out your butt. You can have Addison's or spironolactone, which causes you to retain some acid. And then something you should know, things like saline, because it has chlorine in it, or IV nutrition, because it seems to be acidic. All right, and one last thing is renal tubular acidosis. Renal tubular acidosis. What is renal tubular acidosis? This basically means your kidneys aren't working. Your kidneys aren't reabsorbing bicarb as it should, and that's why you're getting acidosis. Or it's keeping hydrogen, and that's why you're getting acidosis. So there are many different types of renal tubular acidosis. Hopefully I can erase this. You can have type 2 working in your PCT. What in your PCT reabsorbs bicarb? Hopefully you said that in your PCT you have your sodium hydrogen pump, and that will help you reabsorb bicarb. I'm not going to go through the whole cycle. But if you block that, or if it's defective, like in Fanconi syndrome, we talked about that earlier, then you can't reabsorb bicarb, you get acidosis. Absolutely right. You can have type 1, which works in your alpha intercalated cells. And these, we said, secrete hydrogen. And if these don't work, then you can't secrete hydrogen, you get acidosis. Absolutely right. Hopefully nothing too difficult there. And then you have type 4. Type 4 is due to a failure of aldosterone. We already kind of touched on that. We have our ENaC channel that takes in sodium, pumps out hydrogen, pumps out potassium, and aldosterone works on here. If you have aldosterone failure, or if you have Addison's, or if you have something blocking aldosterone like spironolactone, then you don't take in sodium. You don't pump out hydrogen, so hydrogen stays. You retain it, you get acidosis. That is acid base in a nutshell. Hope that wasn't too bad. I'm about to make it a little bit more difficult. Like I said, in physio, they always like to complicate easy things with things like graphs and things like charts and stuff. So let's make some graphs, let's make some charts. One common chart you might see looks like this, where you have pH on the bottom. So this would be low pH, 7.0, say 7.4, 8.0. Here will be bicarb, and bicarb increases here. I'm not going to put in units, 24, 50, 0. So we're missing one component. We're missing CO2. You're absolutely right. So this can be a little tricky, but this is what CO2 looks like. And so CO2 will be up here. So 120, 100, 80, 40, 20, 0. All right, so here it's high to low. And graphs commonly look like this. I'm just going to draw it out for you, okay? There's one more in my notes, and I want you to follow along so you don't have to painfully watch me write it all out. This marker right here is normal. This is where we should be. Everything to the left, everything with low pH is acidosis. So these three are all acidoses. Everything to the right is going to be a high pH. These three. So these three are going to be alkalosis. If you look here, the bicarb is low. That means the acidosis is due to low bicarb. This is metabolic acidosis. Metabolic acidosis. If you look at these two, they're kind of running up on these high CO2. So this is respiratory acidosis. Respiratory. Again, look here. Again, look here. This is all alkalosis. Here, your bicarb is through the roof. So you know this is metabolic alkalosis. You're getting alkalosis because you're retaining bicarb. And these two are running along low CO2. You breathed out all that CO2. Respiratory alkalosis. Respiratory alkalosis. Well, why do we have two respiratories? Well, we said that you have compensation, right? So you get renal compensation. But it takes a while. It takes a while. So the one that is furthest away from the normal, is going to be acute. Compensation hasn't happened yet. The one that's closest to the normal is going to be chronic. It's been a week and your kidneys are starting to compensate. Your pH is starting to return to normal. It never gets to normal. That's one of the rules. It never fully gets to normal, but it's closer. Again, right here, this is further away from the normal, so you know this is acute. Your kidneys haven't helped yet. But then once your kidneys start to get into this groove, starts to help, your pH starts to return to its normal. So this is going to be chronic. And that does it. That graph's a little bit more messy, but if you pull up the graph on my notes and you kind of watch me as I'm doing this, hopefully it makes a little bit more sense. That does it for acid-base homeostasis. Hope you enjoyed the video. Thanks.